Hello everyone, this is a video lecture for Calculus 2 section 7.5, Strategies for Integration. Though I don't think strategies make sense, maybe I would say tactics for integration. There is actually a difference. Regardless, there's nothing new here. They're just wanting to do weird problems, and that's what we're going to do. We're going to do weird problems. So I got integral of 7 sine cubed of x all over cosine x dx. Go! Yeah, I don't know about this one. Well, one thought about this is this cosine down here is not very friendly. If I wanted to do a u is equal to cosine x, my derivative would be a negative sine x dx. We got some signs in the top, but I don't have them I don't know, good looking. I don't have it good looking. Let me go ahead and solve for dx. So I got du over negative sine x. That's a one way to do it. And so I'll just plug in what I got. Sine cubed of x. I've got my cosine x. And then my dx here is being replaced with the du over negative sine x. Well, one of these is going to cancel. That negative will come out to the front with the 7, leaving sine squared x all over... Oh, I forgot. Hold on, that's a u, isn't it? Isn't that u? U. Same thing, it'll be fine. Du. So, like, these are cool, but I still have this sine squared here. How do I tackle that? Well, I remember there's a formula that might convert stuff around. What about sine squared is equal to 1 minus cosine squared? I think that's called Pythagorean. It's just a variety of it, a version. And so I can replace that with 1 minus cosine squared x u du. Thankfully, I could split this up. Two negatives make a positive. And also, thankfully, that's right there. My cosine is simply a u. So I got u squared over u. Well, those cancel there. See, it's not looking too bad. ln of u. On this side, I just got a plain old u. So that'd be u squared over 2 in the end. Plus c. Of course, I plug back in my u, which was a cosine. X. 7 halves. Cosine squared x plus c. There you go. We did it. That was it. Next question. As you can see, there's really nothing new here. It's just using what we already have on, I guess, what you would call weird problems. So x over x to the 4th plus 16 dx. And I need to solve this one. Again, it looks like this will be like I don't know, some kind of u substitution thing, or maybe arctangent. I keep feeling arctangent's right around the corner every time. But x to the 4th doesn't make sense. I like the 16. That's 4 squared. But what is this guy? Well, what I'm going to do is rewrite it as x squared squared plus 4 squared dx. I'm going to do u substitution, saying u is equal to x squared. Du is 2x dx. Divide by the 2, etc. So this right here, these go away. You divide by the 2, 1 over u squared plus 4 squared du. So I skipped a couple steps there, but the idea is all the same. Oh, hey, look, this looks like arctangent. And so we got arctangent of... Actually, I messed up slightly here. Let's back up just a tiny bit here. Because I have the 4 here, this will actually be a 1/4 in the front. Arctangent of u over 4. I know my u's and 4's look so similar. And I'm sorry about that. Arctan of x squared over 4. There you go. Ta-da! Again, arctan, you can interchange them. No big deal there. 75016. So I've got integral of 5t sine t cosine t dt. That's a lot of t's. This right here looks very familiar. I know I've seen that before. So sine of 2t is equal to 2 sine of t cosine of t. Isn't that what that is? Yep, I think so. And so we have this portion. So what I would get is when I divide by 2 on the other side, I get this thing divided by 2. And so if I do that, I got 5/2 now in the front. Integral of t, because there's that t right there still. And then I got my sine of 2t. Oops. Well, I zoomed in just to make an effect. No, it was just a mistake. So that's different. What do I do now? What about my integration by parts? So I got my t equals u, or u equals t, du dt, same thing here. I'm going to use this as my dv. Well, that as my dv. And so when I integrate, my integral of the sine turns into a negative cosine. I have to divide by the 2. And there we go. So uv minus integral v du. Just copying it down. And now I can actually integrate this guy. Very similarly, my 2 negatives will make a positive. The half can come out. Integral of the cosine should be a regular old positive sine, but I'm going to divide by the 2. And so then I got a half, and I got another half, and then I got my sine of 2t and then plus c. I got a slightly different answer. I got 5s and... Oh, my 5. Where's my 5 go? Right there. 5/2. Did I just mess up here? Oh, I know. Correct. All this is good. I just had the 5/2 in the front, so all of this is still times the 5/2. That was definitely my bad. Negative 5/4t cosine of 2t. Yeah. That's a 4, makes an 8 now. 5/8 sine of 2t and then plus c. The c absorbs the 5/2. You don't have to worry about that. Okay, I made a small mistake, but we saw it. 75036. So I've got integral sine of 5t cosine of I'm sorry, not 5t. Let me just re-say that. Sine to the 5th of t, cosine to the 6th of t, dt. Yeah, what is going on here? So I have a little note here in my notes. It says, I split up the sine because it was odd. Okay. Now, what am I saying here by split up the one that's odd? So imagine 5 steps ahead, where you're going to have a u substitution. U is going to be a sine or something like that. I don't know. Du is going to be your cosine, t dt. And the point is, sine or cosine, whatever, I'm going to have a single term with my du. So I have to use one of these to attach with this dt here in a minute. Okay, so I'm choosing the odd number, the odd power, for specific reasons. So this is technically incorrect, but it'll be flipped. It's cosine and a sine. You'll see that here in just a second. So notice that I didn't actually do anything wrong here. I have a 5, so I'll make a 4 and a 1. Okay, so this will be my du here in a minute, I'm sure. Let me just kind of let him hang out for a minute. In order to make that work, I actually want, like, okay, if this is going to be my du business, yeah, then what's the integral of that? Well, it's sine does not derivative to sine. It's like cosine goes to a sine. So I want a lot of cosines. I like this, but this is still not exactly right. Good thing we had the Pythagorean theorem-y stuff like that. So this is technically a sine squared, cosine to the 6, sine dt. These two will change into 1 minus cosine squared. 1 minus cosine squared, cosine to the 6, sine dt. Again, that's my du business. And now I could say that my u is going to be a cosine. What are we using t here? Du would then be my negative sine t dt. You can see I'm already creating it, so that's good. I just don't like it exactly the way it is because we have to do a couple more steps, but let's just go ahead and plug it in. It'll be fine. So I need that negative, so I'm going to put a negative in the front to kind of compensate, I guess you can say. So I got 1 minus u squared, 1 minus u squared, u to the 6, and then just du. This whole thing turned into a du here. I know I didn't do my full steps, but they would cancel and you leave a negative sign out there. Yeah, you need a FOIL. It's going to be a lot of FOIL here, and that's okay. So I got 1 minus 2u squared plus u to the 4th, u to the 6th du. Distribute, distribute, distribute. I know it looks like a lot, but what you're actually creating here is a big polynomial thing. When you multiply your bases, you add their powers. And so here we're going to get a 10. And so each one of those is actually very simple to integrate. And so I got u to the 7th over 7, negative. I got a positive now. Remember how I'm distributing it here. Positive 2u to the 9 over 9. And then I've got a negative u to the 11 over 11 plus c. Go ahead and just plug back in my cosine. It was a cosine, wasn't it? Yeah, my u was a cosine. So I got cosine to the 7th over 7. 2/9 cosine to the 9th. And that's a negative. Cosine to the 11 over 11 plus c. There we go. Why do I have a 13 on my answer here? Let's pause for a second. Did I mess something up here? I thought I multiply your bases, you add their powers. You add the, yeah, 6 plus 4 makes a 10, right? Why do I have a 12? Apparently I had a 10, so why do I have a 12 there? Hang out for a second here with me, okay? 6. I got my 8, I got my 6, and then I have a 12. 4 and 2 and 2 will make a 4, won't it? Yeah, I got the 4. Huh, I don't know why I have that other number. Well, I must have made some kind of small mistake on my notes. It's kind of weird because normally I double check everything there. So when you get to this question, just be careful. And I mean, I don't think I'm doing anything wrong. You simply say 4 plus 6 is 10, and then you make an 11. And it even looks like I had. I see what I had done. I did something else. But regardless, this is what I would say is the answer. I don't know. The one I have on my notes is the 13. Just watch out. Either way, I don't know. There might be something I forgot. Something tiny. And you know, that's okay. It happens. Because we're all humans. So that's okay. It's okay to be a human. Humans are cool. We like humans. So I got x, secant x, tangent x, dx. And yeah, solve this thing. Now what do we do? I don't know. This, like, right here looks familiar, right? So derivative of secant is secant tangent. Yeah. So where's my secant, though? I'm lost. I don't have that. And so how can I go about figuring this out? Well, I'm going to do the integration by parts. So I got my u is equal to x. Du is dx. This whole thing over here, again, is going to be my dv, because when I integrate this, like I was saying, derivative secant is secant tangent, so going backwards, you get a plain old secant x, and that's happy days. So my answer is uv minus integral of v du. Du is a dx in this particular case. In order to do this, I would say formula, and so, like, don't even waste your time. It's just a formula, and you're going to memorize that formula just as I have. It's ln of secant plus tangent, just like that. Plus c, cool, walk away. Next question. I'm hoping you're seeing that these problems are not as hard as the previous sections, and that's good. It's just, you know, we got to do it, and that's all part of it. 13 ln of x divided by x times the square root of 1 plus ln of x all squared there. Just like that, dx. Okay, well, I'm feeling like the x is my u substitution or my ln x. Notice it's complicated inside and maybe something cancels up here. I don't know. So let's do u is equal to ln x. My derivative is 1 over x dx. And that makes sense with this guy now. So dx is equal to x du, just like this. Oops, du. Plug in those two in. 13 in the front, I got a u, I got an x, I got the square root of 1 plus u squared, and then I got an x du. Cancel those two x's out entirely. So now I'm left with this guy. So I'm wondering what to do now. I'm always feeling like it's an arc tangent. It's not. I'm going to do a new substitution, not u substitution. I'm going to do a v substitution. So that complicated inside for sure is, I hope can go away, or at least be simplified somewhat. So du is equal to dv over 2u. So if you run out of u, you just go to v then, right? I guess. And then you go to w. Yay! How fun would that be? 1 plus... actually, it's not 1 plus anything. It's just going to be my v down here, just straight up. dv 2u, my u's cancel. The 2 comes out to the front. And so I actually got v to the negative 1/2 dv. So when I integrate, I add 1 to the power, and I divide by that new power. This half in the bottom flips to a 2 in the top, which actually makes the 2's cancel, leaving a 13 square root of v plus c, which is 13 square root of 1 plus u squared plus c, which is, again, 1 plus, and that's the ln of x all squared, and then plus c. There we go. Whew. Next question, 75035. I've got integral of 25 dx divided by 25 plus e to the x. Seems simple enough. Not really. I'm going to do the whole denominator as my u substitution. So du is equal to, well, just e to the x dx. And that seems kind of basic, and that's going to be okay. Watch what happens. This is kind of funny, like a double loop thing. And I find like this is where some of the strength in my third step here comes in handy. That 25 can come to the front. My dx is replaced with the du over e to the x. And then in denominator, I just have a plain old u. Okay. My problem is I don't really know how to figure this thing out because, look, I didn't cancel everything. Well, couldn't I solve for e to the x here? Couldn't I subtract 25 on both sides? And so what I've got now is 25 integral of, and these are both in denominator technically. I have my u minus 25, and then I have a plain old u. Cool. Yeah, great. Now what? Well, I turned a page. That's what I do. Oh, I see what I did. So, you guessed it, partial fractions. Yay, how fun. So we got a u. Not this again, no! These are going to be pretty basic compared to what we've already accomplished, so you'll be fine. This is a du technically here. Okay, so find out what my a and b are, multiply by the opposites and all that kind of stuff. So a times its opposite, and b times its opposite. And this whole thing here is right here. You see it? 1 is equal to 1, or I guess you can even say 0u plus 1. So all my u's, my au plus bu, should equal 0u. And then my negative 25a, well, is equal to 1. This is super easy, so a is equal to negative 1 over 25. Okay, and so that also means then that my b is equal to a positive 1 over 25. Cool. Let's go back to my question now. I got 25 integral of negative 1 over 25 over u, positive 1 over 25 u minus 25 du. Well, it's funny because these are both in denominator and this 25 here is numerator, and so all these guys are going to cancel out. That makes it a little easier. I got negative ln of u, and here I've got v substitution if you want to go that far, but ultimately it'll be another ln plus c. My u's, of course, can change back into, what did I have for u? Let's go back. What did I have for u? 25 plus e to the x. Got 25 plus e to the x. And then if I plug this in as 25 plus e to the x minus 25, they actually cancel the 25s, leaving just e to the x. Nice. Oh, I actually went one step further. You ready? This is actually one step further. E and ln cancel. So you can actually say x minus ln of 25 plus e to the x plus c. There you go. Now that's awesome. Next question, 75075. And so I've got integral of 6 divided by the square root of x plus 6 plus the square root of x dx. So there is one way to do this problem. I mean, you can think that, oh, there's always multiple ways. The way to do this problem is multiply by the conjugate. Multiply by the conjugate. This is a step that is fairly rare. I would say it's rare enough that I don't think about it as a possibility until like I get it wrong 50 times and what do I do now? So multiply by conjugate. What you're going to do is you're going to multiply this both the top and bottom by x plus 6 minus square root x and the square root of x plus 6 minus the square root of x. Okay, so notice the conjugate is the opposite of sign in the middle, but both in top and bottom means that I'm not really doing anything wrong. So what you actually have to do here is FOIL this thing out. And the reason why there's plus and a minus here is actually a lot of stuff cancels. And so I have these two square roots turn into a regular. Positive, negative, they cancel, and then x and x makes a regular x, actually. Square root of x and square root of x make a regular x. Notice again here that I got x plus 6 minus x. These x's cancel. And then I got 6 in the bottom and 6 in the top, and those cancel. And so I ultimately end up with this guy right here, which is much easier, much, much easier. Add 1 to the power, divide by the new power. For both of them. And, well, there's your answer. I guess you can make it look pretty if you like, so whatever. Ta-da! Wow, that was not too bad. And then 75073, I've got integral of 6 sine of 2x divided by 1 plus cosine to the 4th power x dx. Okay, how do I make this one work? I'm always feeling that art tangent. I don't know if it's really there or not, but basically here I got 1 squared technically, and this right here is cosine squared squared. And so what if I just did cosine squared x is my u? So du, what's my derivative of this? The 2 comes down, leave the inside alone. 1 power, chain rule, derivative of cosine's a negative sine x dx. And this is just way crazy to just try to think about doing it alone. So I divide by all that stuff, and we'll figure out the math here in just a second. So I'm going to plug that stuff in, plug that guy in. Let's see what happens. So 6 is in the front. I got the sine of 2x. Don't know what about that guy. 1 plus my u squared, and then I got my du divided by -2 cosine x sine x. Well, here's my problem, is that nothing's really canceling. I was thinking they were going to cancel. Well, they do, actually. This guy is literally equal to that one. Those are literally equal to one another. So I'm not even going to like play around here. They just cancel. Those are the same. And the negative right here can come out to the front. So -6 integral of 1 over 1 plus u squared du. And then, that definitely looks like an arc tangent to me. See? I get it once in a while. Once in a while it works. So that 1 right there makes this super easy. That's now 1 over 1 arc tangent of u over 1 plus c. My u was this cosine squared. So I could just say cosine squared x on the inside, like that. There we go. And there you go. You're done. And actually, that's all I have for this section. There's not a lot going on. It's actually pretty simple. I hope you've enjoyed this video over some of the other ones. Thank you very much. Have a great day.